Alrighty, now that we got that not-so-quick start out of the way, what we're going to be doing is we're going to start looking at some of the internals of Android. What I mean by that is I want to take a look at the Android SDK itself and talk about Android API levels and go on to discuss the Android build system. So, for the next couple of videos, we are not actually going to be using Android Studio. The reason for that is, in reality, Android Studio is built on top of a build pipeline that Google provides us, and it's completely usable outside the context of Android Studio. And that gives us a great opportunity to sit down and talk about things like the directory structure, the different required files and different settings and all that fun stuff, without being clogged or without the conversation being interrupted by the magic of a Android IDE. So it's going to take a couple of videos, but we're going to become, at least get a nice overview feeling for how Android applications are compiled, deployed, and ran behind the scenes. Now, this isn't something that you would need to do very often, but what it allows us to do is debug issues if they were to come up. If for some reason the build pipeline were to break, we would be able to more easily debug them. Especially since when we go to create an Android project from the command line, there's actually a bug in there that we'll be able to fix and show an example of why, well, knowing this stuff is important. Finally, the last part of this little mini-series of videos, what we're going to do is we're going to use the Android build pipeline to show you how to create an app that you can have multiple versions of. For example, a free versus paid version, or a light versus standard version. We're not going to talk about monetization or anything, but more specifically, how would you go about implementing that within the same code base? Because previously, in previous versions of the Android build pipeline, that wasn't possible to do very easily, but now it is. So before, in this video, all I really want to do is I want to talk about the Android SDK. What it is, what's in it, and how to understand and work with the different versions of your targets and your build tools. So in order to do that, the first thing you guys need to understand are API levels. Now, put very simply, an API level is a version of the Android SDK. You can think of it like that. I mean, that's not technically correct, but for all intents and purposes, an API level is a set of APIs, or a version of an API. I would have preferred that to be called API versions, but it's not. Now, the interesting thing about API levels that people might not know off the top of their head is how it relates to the different Android versions, because I'm sure most of you guys are familiar with things like Eclair and Honeycomb and KitKat and all those names, and you might be familiar with the versions of Android that corresponds to. The important thing to understand as a developer, however, is how those versions correlate with the API levels. Because at the end of the day, it's the API levels that we're most focused about when dealing with development. We don't care that we're developing for Lollipop or KitKat or whatever. We care that we're developing for API level 21 or API level 19. So what we need to do is we need to understand how that correlates. Now, it doesn't correlate in a very systematic manner. It's actually rather sporadic how the versions align with each other, but fortunately Google gives us some documentation that will lay that information out for us. So what I'm going to do is I'm going to open up Chrome. I'm simply going to search Google for Android API levels. And we're going to see a result right here. If you're just interested in typing in the address, it's going to be source.android.com/source/build-numbers.html. And we're going to open that up. And it'll give us this nice table. Now, you'll notice that every single row of this table is a different API level. Over here on the right-hand side, you see we start off with API level 1, and we end with API level 21. Now, the other two columns associate the code names of that Android version with the version number of that version, and then, of course, finally to the API level. So we'll see all of our desserts on the left-hand side. We'll see version numbers that we might be more familiar with on the middle, and then finally these guys over on the right. So again, API levels are really just versions of the API. Now, the target version is basically going to be the upper bound of what features that we can use. So seeing as these API levels are different versions, Google may introduce new APIs, or they may deprecate old APIs, or they may completely remove other APIs. Now, when we target a particular API level, that is the upper bound of what features we're allowed to use. If we target a particular API level and we try to use a feature that only exists in an API level above it, well, that's just not going to work. So our target API level defines the features that we're able to compile. The features we're able to actually physically reference is the target API level. Then we have the minimum API level. Now, the minimum API level is really not surprisingly the minimum API level that is supported by our application. Meaning, the minimum API level we can use all of the features of without having to worry about anything. Because it's physically impossible to deploy an application with a minimum API level that is greater than the API level of the current device. So the minimum, we can use any feature from the minimum API level, and we can use any feature of the target API level. But if we use a feature of the target API level, we may have to wrap it in a conditional statement saying, is the current device I'm running on at that particular API level or not? It'll let us compile up to it, but if we deploy, let's say we have a target API level of 19 and a minimum API level of 1, which for some reason, and we try to use something that was introduced in Honeycomb, right? Well, if I tried to launch that application on the device that has an API level of 1, it would compile, it would launch, but then when I tried to use that feature, it'd crash. Okay, so target and minimum API levels are important to specify, and that range is really like I said in the last video, that range is really important. That range is, we want to target the most amount of devices that we can. So you really want to, well, you really want to, for example, between KitKat and Jelly Bean right here, this is what, we saw in the last video, is like 70-80% of all devices are what I have selected. That's a good compromise. This will give you a good compromise between compatibility and ability to use features. So for this series, I'm going to have a target API level of 19 and a minimum of 16. Anyway, you won't notice a whole lot of rhyme or reason about how these code names match up with their version numbers. You see, like, there's 3 eclairs that have 3 different API levels, but there's only one donut that only has one version, one API level. And then we have, like, gingerbread between 2.3 to 2.3.2, but then 2.3.3 is another. So don't assume that just because there's a new version out that it is or isn't a new API level. Always refer to the documentation. Final thing I want to point out about API levels is something that people who are paying very close attention may have noticed. There is no API level 20. Well, actually, there is an API level 20. The API level 20 is everything in KitKat plus the Android Wear API. So if you're interested at all in Android Wear devices like little phones and smartwatches, or not phones, those little smartwatches and stuff like that that have really yet to become mainstream. We'll see how Apple Watch does. But anyway, that's what API level 20 is. So you'll never be using API level 20 in your phone-only applications. You'll be using either API level 19 or API level 21. Okay, so yeah, that's our API levels. What I'm going to do here is I'm going to close out of Chrome, and I'm going to open up the folder where my Android SDK is loaded. So if you recall, when I installed the Android SDK, I put it into a more global location on my computer as opposed to my app data folder. Now, if you left the default location of the Android SDK, you'll have to go hunting in your app data folder. But if you didn't, let's hop on over to my C drive, my software folder, and we have Android right here. Now, the great thing about the Android SDK is this isn't something I've really mentioned before, I don't think, up until this point. It allows you to install all of the API levels that you want, as well as any additional tools. So you really only need one SDK installed on your computer, and then you can have it install different versions of Android depending on what you need. We'll look at that momentarily once we get down to the bottom of this folder and look at the SDK manager, but For now, let's go ahead and just go through each one of these folders one by one really quick, just to dispel some of the magic that you might be like, oh no, a new thing, bunch of folders. Well, let's go ahead and just take a look at them. First one, you see add-ons. And you'll see add-on, inside of add-ons, we have add-on Google APIs at Google 21. Well, what are the Google APIs? The Google APIs are the things like the Google Maps and stuff. It's things that don't necessarily have to be present on Android devices, but commonly are, because commonly you have these particular packages installed on your Android device. And that's what the Google APIs are. So, for example, Maps, which technically isn't part of Android, but for all intents and purposes, it is. What's interesting about this is the Genymotion emulator virtual devices that we're using don't include the Google APIs, which is unfortunate. And we will be installing them later when we need them, because we're going to be needing Google Play services. But for all intents and purposes, these add-ons are typically available on the run-of-the-mill Android device that a user has. Next up, we have build tools. So we see we have 21.12 in here, and these are the build tools. They help create our APK files, and we'll see what those are later. Those are the Android packages, the actual unit of distribution for an Android application. So this folder is full of all sorts of fun stuff, like creating compiling your resources, turning your class file or your .class artifacts from the Java compiler into DEX files that are understood by the Android VM, and all that fun stuff. Okay, then we have documentation. This is a local copy of the Android documentation. I've never had a reason to use it. I guess if you're stuck on an airplane somewhere and you need the documentation, you can use that. We have extras. Now, extras is, well, it's just extra stuff. For example, if I click on Intel, we'll see that Haxum thing right here. Remember how I talked about Haxum a couple videos ago, how it's the thing that Intel made that speeds up the emulator by turning it into a virtual device, but unfortunately falls short because it's a bit buggy on Windows. This is where that will install to. So if you did want to install it, you would come into this folder. We have platforms. Now, platforms is going to be, well, the platforms that we have installed. And you'll notice where here we have the Android 21 installed, which is the Android API level 21. And this will contain things like the Android jar, which is, well, Android, that we're going to build against, and all that fun stuff. Next up, we have Platform Tools, and Platform Tools contains a really, really nice executable here called ADB. Later in this video, we'll be adding this Platform Tools to our path so that we can access ADB from the command line. It also contains things like Fastboot, which you can use to replace your bootloader on your device, and which is a process that you have to go through if you wanted to root it, for example. Then we have sources, which should be pretty self-explanatory. Under here, we have the entire source code of Android API level 21. So if I go into like com, Android, hey look, there's a bunch of source code, Java source code. So super fun stuff. There we go. We have our system images, which our system images are going to be the emulator device images that are installed when we use the emulator, which we're not going to, so it's really irrelevant. Temp, I don't really know what this folder does besides be a temporary folder for whatever operations Android needs to do. And then we have tools, and tools is full of some fun stuff, particularly our monitor and our Android. So our Android bat file right here gives us some really nice little tools to do things like create an Android project from a template. And then our monitor right here provides us with some really awesome debugging tools to actually peek into a run instance of Android or an Android application and do things like decompose its view hierarchy and all that fun stuff. We'll be using the monitor for certain things later, but fortunately Android Studio itself has a lot of these debug tools built into it, so we will very rarely have to launch monitor itself. But anyway, so these are just, it's what it says on the tins, they're tools. Okay, finally we have these two executables. We have the ABD manager and the SDK manager. Now the AVD manager, if I go ahead and launch that, maybe. Let's see if it's like throwing an error there. No, it just doesn't want to launch. It's probably because I've talked so badly about the Android emulator throughout this series that it just decides that it's just not going to launch. It doesn't want to put up with me. And you know what? That's fine, because I don't need it. The AVD manager is the Android Virtual Device Manager. Use it to create emulators and that stuff, which we're not going to do, so I don't really care too much about it. The SDK manager, on the other hand, also won't launch. You know what? I think I might have a small problem with my installation of Java. I'll be right. Well, I'm not going to dwell on this too much because I found an alternate way to launch this. I'm not entirely sure why those executables don't work, but they don't. So let's go ahead, and what I'm going to do is I'm going to launch a command prompt, and I'm just going to type in tools/Android and hit enter. And so when you launch the Android bat file without any parameters, we get our Android SDK manager. So sorry about that, guys. So yeah, now what we see here is basically all the stuff that we can download. So all the different API levels. You'll notice that our Android 5 has already been downloaded, and that was automatically downloaded for us, or our API level 21 has been downloaded. That's been downloaded for us during the installation process of Android Studio. So we have our SDK, we have our Google APIs, for example, we have our SDK platform. This is the stuff that's already installed. What we don't have are some of these things that are checked over here. Like, for example, we don't have some system images, we don't have the Android TV or Android Wear system images. But you know what, that's all fine, because we're not going to be using any of that. In fact, Android Studio happened to download everything that we need to work with Android. We don't need anything else. But if you didn't get your SDK through Android Studio, I would recommend going ahead and installing your SDK platform for API level 21. So you'll also notice we also have our build tools, and we have our different build tools version numbers that we see here. So we have the current build tools installed, and we have different... this isn't that exciting, actually, guys. So, but if you need to go in here, we need to update your Android SDK or install a new one or install an old one, then go ahead and hop in here. Otherwise, you really don't need to worry about it a whole much. Let's go ahead and close out of that. And close out of that. So I think that pretty much just wraps up what I want to show you guys, what the Android SDK is, what the different API levels are, and all that fun stuff. And that's pretty much all I wanted to do in this video, except for one more thing. I will be launching the Android bat file from my command line, as well as ADB from my command line. Also, by the way, I did turn on file extensions while I was gone for a moment, just in case anybody noticed that. But anyway, I want to be able to launch these from the command line from no matter what folder that I'm in on my computer. So what I'm going to do is I'm going to add them to my path. So I'll show you guys how to add something to your path in Windows 8 really quickly. It'll be a little different on Windows 7. But what that'll allow me to do again is it'll allow me to access ADB no matter where I am in my command prompt. So for example, let's go ahead and open up a command window on my desktop. And if I typed in ADB, notice how it says it's not recognized as an internal external command. But I want to be able to do that for convenience purposes. So what I'm going to do, I'm going to close out of that. I'm going to hit start. I'm going to just start typing in env. And the first thing that's going to come up in Windows 8.1 is going to be edit environment variables for your account. So I'm going to click on that. And it'll launch a hopefully familiar environment variables dialog. And I don't already have a path variable, so I'm going to hit new. And for the variable name, I'm going to call path. Now for the variable value, again, I want to add 2 paths to my path variable. So the first one is going to be under platform tools. So I'm going to grab this entire path on my address bar, right click and hit copy, and then come here and hit paste. Then, since I want to add another path, I'm going to hit semicolon, because in Windows, that's how you delineate paths on your path environment variable. And I'm going to come back into here to Android. I'm going to open up Tools. I'm going to right-click Copy, come down here, and right-click Paste. And that will add those two values to my environment variable, or path environment variable. I'll just add another semicolon there for the next time I add a path. So I'll go ahead and do that. And I'm going to go ahead and hit OK. And now, when I launch my command window, I can type in ADB and see how I get this terrifyingly long help document thing. But that means it was able to find it. Quick note, if you did not close and reopen your command prompt and you tried to type in ADB after adding your environment path variable, it will still not work. Environment variables are loaded on processes every time you launch them, meaning you're going to have to close your command prompt and open it up again. Then, if your path is set up correctly, you'll be able to type in ADB and get all that, or we can type in Android and get our SDK manager. We also use the Android command for other things, but for now, stuff and things. So yeah, I think that pretty much wraps up what I wanted to do in this video. In the next video, we'll actually look at creating an Android project from the command line and going over its directory structure. So, we'll see you guys in the next video.